Hey everyone, and welcome back to The Explainer. I am absolutely thrilled you're joining us today because we're unpacking a truly fascinating tale of two interconnected water systems right here in India. We're going to start by looking at the incredibly fragile, bustling life along the salty coastlines, and then we'll trace a parallel story deep inland to the country's most vital freshwater artery. So it's a story of jaw-dropping biodiversity, unprecedented threats, and these massive human efforts to turn the tide. And ultimately, it's a story about how the survival of these ecosystems directly impacts our climate, our coastlines, and the water we drink. Let's get right into it.
Here's a quick look at the agenda for today's explainer. First, builders of the reef. Second, India's diverse coral landscapes. Third, the coral bleaching crisis. Fourth, rejuvenating the river Ganga. And finally, India's aquatic conservation efforts.
Starting with Section 1, Builders of the Reef, a microscopic marvel. You know, while you might think of coral as just colorful rocks, they're actually tiny, living animals called polyps that leave behind massive limestone skeletons.
Okay, let's dive into this. Meet zooxanthellae. It's a bit of a mouthful for sure, but it is essentially microscopic algae, and it holds the secret to the entire coral ecosystem. Here's what's so amazing to me. The tissues of corals themselves are not actually those beautiful, vibrant colors we always picture. Coral tissue is naturally clear, or just straight white. The corals receive all their spectacular coloration entirely from the zooxanthellae living right inside their tissues.
What's really interesting is how this operates like the ultimate underwater roommate agreement. This is a classic symbiotic relationship. On the left side, you have the host coral polyp, giving the algae a highly protected environment to live in, much closer to the surface light, along with a steady supply of carbon dioxide. And on the right, the algae repays the rent through photosynthesis. It gives the coral fixed carbon compounds for energy, it enhances its ability to calcify and grow, and of course, gives it that vibrant color we just talked about. They literally rely entirely on each other to survive.
And because of this hyper-efficient roommate agreement, corals can survive even in really nutrient-poor waters. The whole community recycles scarce nutrients so incredibly well that they allow for extremely high productivity. It's like a giant puzzle where nothing goes to waste. Invertebrates, vertebrates, plants, they all flock to these structures, creating a level of biodiversity so incredibly dense that coral reefs have earned this famous nickname, the tropical rainforests of the oceans.
Section 2. India's diverse coral landscapes, from coast to atoll. We know how they're built at a microscopic level, so let's zoom out and shift our focus to the macro scale. 19,000 square kilometers. That is a massive, rough estimate of coral reef cover spread across Indian waters. To put that into perspective, it's an area of immense biological importance. These reefs aren't just pretty to look at. They are natural, physical barriers against erosion and storm surges. They provide a rock-solid foundation for mangroves, and they happen to be the largest biogenic calcium carbonate producers in the entire sea.
And those 19,000 square kilometers are incredibly varied. India actually hosts 4 major classifications of reefs based on where they're located. You've got fringing reefs, which are contiguous with the shore, mostly found in the Andamans. Then there are patch reefs, which are isolated and discontinuous, popping up in Palk Bay and the Gulf of Kutch. Barrier reefs are these cool offshore linear structures running parallel to the coastline, creating lagoons. You'll see those in Nicobar. And finally, atolls, those beautiful circular reefs in Lakshadweep and Nicobar. And among all of these, the Andaman and Nicobar Islands boast the absolute richest species diversity of the bunch.
Section 3. The coral bleaching crisis, when the agreement fails. Sadly, we have to shift to a much more serious tone here, because these majestic ecosystems are facing unprecedented degradation worldwide.
So, what does this all mean? What happens when environmental stress breaks down this fragile underwater roommate agreement? I mean, we've established how much the coral and the algae depend on each other. So what actually happens, physically, when environmental stressors force this perfect symbiotic agreement to just fall apart? And this brilliantly illustrates the exact tragic sequence of coral bleaching. Step 1. A stressor, usually a temperature shock, disrupts the environment. In fact, when waters spike to just above 30 degrees Celsius, the algae's photosynthesis pathways are completely impaired. Step 2. The coral effectively evicts its roommate, losing 60 to 90% of its zooxanthellae. Step 3. Without the algae, the coral loses its vibrant color, turning a ghostly pale or white. Now, if the stress drops, the algae can return. But Step 4 shows us the grim reality. If the stress is prolonged and the algae doesn't come back, the host coral simply starves and dies.
Now, there's a whole list of ecological stressors here that can trigger this, things like solar irradiation, freshwater dilution,
or sedimentation from runoff, but I really want you to focus on the very top of this list. Temperature is the major cause. The rapid warming of ocean waters remains the primary, overriding culprits causing these corals to reject their algae and ultimately starve.
Moving to Section 4, rejuvenating the River Ganga, a freshwater parallel. Because as it turns out, the battle for India's aquatic health isn't just happening out on the coasts.
From the fragile saltwater coasts, we're pivoting deep inland to India's most vital freshwater ecosystem. Just as the ocean reefs suffer from severe human impact and pollution, the mighty river Ganges has faced a mirroring crisis. It's a vital freshwater artery that sustains millions of lives, but the sheer volume of municipal sewage and industrial waste pushed it to the absolute brink. And that has required some intense, massive government intervention to start turning things around.
If we look at the timeline, the government's approach has evolved dramatically over the decades. It actually started way back in 1986 with the Ganga Action Plan, which was mainly focused on intercepting and treating domestic sewage and industrial waste. Then, recognizing the need for much more aggressive action, 2009 brought us Mission Clean Ganga, with a really strict target of zero untreated waste released by 2020, which eventually evolved into today's strategy, a comprehensive integrated conservation mission known as Namami Gange.
Section 5. India's aquatic conservation efforts, solutions in action. Let's bring both halves of our tale together and see exactly what policy solutions are being deployed.
So, the crucial point is how these legal frameworks act as a shield. For the coasts, we have a really robust system in place. The Coastal Regulation Zone and Island Protection Zone notifications from 2011 strictly regulate coastal development, meaning almost no new construction is allowed in these sensitive areas. Furthermore, corals are included in Schedule I of the Wildlife Protection Act of 1972. That is a real game changer because it affords them the highest degree of protection under Indian law, and it's all backed up by a massive network of 4 national parks, 96 sanctuaries, and 3 marine biospheres actively shielding these fragile polyps.
And for the rivers, the commitment is equally substantial. 2,037 crores. That is a staggering financial figure set aside for the conservation and improvement of the Ganga under the Namami Gange Programme. And they aren't just throwing money at the water, it is a highly targeted, multi-pillar strategy.
Here's exactly how the Namami Gange program attacks pollution from multiple angles. It's the whole shebang. You have Nirmal Dara, focusing on sustainable sewage management, from huge municipal projects right down to rural sanitation. You have strict industrial management, making zero liquid discharge mandatory for factories. You've got Aviral Dara, enforcing river regulatory zones. And they even established the Clean Ganga Fund, which allows regular citizens to voluntarily contribute to the cleanup, proving that this really is a collective fight.
We've seen the microscopic wonder of a coral polyp trading rent with algae, and the massive macroeconomic effort to clean one of the world's most famous rivers. Both systems are stressed by human hands, and both are now fiercely protected by them. But it leaves us with one incredibly important question to ponder. As waters continue to warm and development continues to boom, will these massive financial investments and strict regulations actually be enough to secure the future of India's aquatic ecosystems before time runs out? Thank you so much for joining me on this explainer. Keep learning, keep asking questions, and I'll see you in the next one.